Alright, today we're going to talk about singly linked lists, and if you want to really learn it, I definitely recommend just typing this out and following along. It's not a whole ton of code, and you can just pause the video and do that, and then I'll just keep going. So I want to start by talking about what a node is. So node is nothing special. It's just a struct, right? Which means it's just a box, and we could call this node potato. We could call it whatever we want, but by convention you'll hear it be called a node for lists and trees and other things. So if you notice in our node, right, we decided to put a string name in it, and we put a node pointer to next. So we made a few nodes here. So node first.name is Alice, so we'll make that node here, and let's do first. Right, and we have a name, NA, I'm just going to call it that, and Alice in here, and then it has a next, NXT, that's what I'm going to call it, and right now it has a junk value in it, right? And then this is just a different way of basically declaring a struct, is you can initialize it like this. It's just a shorthand, it's much nicer in my opinion. So we have second, so let's draw that out real quick. So second, draw it over here, right? And NA is equal to Bob, Coolio, and next is a null pointer. And a null pointer, or sometimes null, are denoted with this right here, a 0 with a slash through it. So that's null or null pointer, right? So for 280, it's a better practice to use null pointer instead of null to give values for pointers. So I'm going to draw third over here and quickly type this in. Apparently writing, you write at, I don't know, someone correct me on this, but it's 15 words a second, and you type much faster than that. So not the best thing. So I'm not going to draw the null in there for now, but normally you would. And now, as you notice, these are just 3 unrelated boxes, right? These could be anywhere in memory. They're not like an array where, if you have an array of something, right, like this down here, you know that these 3 things in memory are right next to each other. So x00, x04, these things are 4 things apart if it's an integer and stuff like that, right? And it goes forever. But these could be all over the place. This could be at x00. This could be x98. Wow, as I draw a 9. Whatever, it doesn't matter. And x42, as every computer scientist thinks that's the funniest joke in the world. All right, so they're not next to each other. So what we have to do is keep track of each one and turn this into a list. So let's do that. Let's do first dot next equal to at second, right? So if we go back to our diagram real quick, this first just points at second. It has this x98 in it, right? And that's it. And now we have a list of 2 things. And now you may be guessing what I'm going to do next. I'm going to make second dot next. I was really close to making third dot next instead, just to trip everyone up. So second dot next equal to at third. And now this gets a value of x42, which means it's pointing here. It's cool. And now we just have a list of things, right? And so a list alone is nice because it's just a data structure, right? And data structure, just like arrays, vectors, or anything else you learn, is just a way of holding data so that you can go through it later. And it's nice if you have structs to just be able to point them at each other. But you just start to realize, instead of just having one pointer, sometimes we'll have 2 or 3 or however many you want, so you can keep track of different things. And this is just singly linked lists, so it's, I would say, probably the simplest of lists, and it's a great place to start. And if you want a problem that will help you a lot is if you type all this out, try and make a print list function that, given a pointer to first here, you will be able to print the value in first, and then an arrow to second, arrow to third, and then essentially make it print out null at the end, right? So I would say pause the video and try that. I'm going to type it out and explain what my thought process is as I do it, but I definitely say try it first. So I'm sorry, so it doesn't have any return type, call it print list, and it should take a node pointer. I'm going to call it root, because sometimes you'll hear this is being called the root of the list or root node. That's usually for trees that have 2 nodes, stuff like that, but you'll learn that later. So let's see, so we should at least see out root and call it name, right? And then put a nice little arrow here. So that'll get us 1, but the trick to this problem is more how do you navigate a list, right? So while I'm going to say root, we're going to print out the name, right? So I know this is wrong right now, but let's see what it does. So we're over here. Oh, it's a little difficult to see. I think I can get rid of this. So let's exit out of here. All right. So we make and we run it. Oh, I gotta call it. Duh. Let's call this print list at first, right? Because it takes a node pointer, so I'm gonna give it the root, which would be the first node, and save it. Make again. And you see Alice is forever printed, right? Because root, it always points to a valid node. It's not pointing to null. This will fail as soon as root. So fails when root equal null pointer or like null, right? So that's when this while loop will break. So the problem with root is it's not moving. So we need to move it. And the way you move things is you go root equals root next. And if we take first for our example, right? And I'm going to do this, bring that back up. And if we take first for our example, right? So first would be root. So we can make this root right here. Woo! That's some big font. There we go. So root would be pointing here. And the next is this arrow. So when we do root next, what it's going to do is now give you an arrow to second. So instead of root pointing here, now root is going to point here. And then it's going to do the same thing, dereference it, and go to next, and boom, down here. Until at third, this is null right here, right? Once it's pointing at third and it dereferences and next, this goes away, and it points at null, right? Because this is pointing at null. And as soon as root is null, the pointer, right, this while loop will break. So let's try that out real quick. Oh, actually, I'm going to end up exiting out of that anyway. So let's do that. Make ./a, and there you go, right? Alice, Bob, Carolyn. So just a nice little touch here. I'm going to do cout null, and then an endl, and you get a nicer looking one. And then in the next video, I'm going to talk, instead of singular linked lists, I'm going to talk about doubly linked lists. And here's just a nice visual on the command line. All right, see you in the next one.